Hi, it's Tommy from Kamostech. Last time we had a look at the first impressions and some features of WiiM Ultra. This week we're going to do a teardown. We're going to see how to open the device and what's inside, what are the main components, focusing on the audio components. Okay, let's start. So the WiiM is made of, there's like one lid, you can see the lines here, and then the case is just one piece around it. So the only way we can open it must be here. Yeah, we have screw holes there. The screws are quite deep there, so you need something that fits there. Okay, then I don't know what comes off. I don't know if the bottom gets off or the lid should get off. Found a suction cup. This is a GoPro holder. I'm not so well equipped for teardowns because I haven't been doing them yet, but if you have any of those teardown kits, you have the suction cups and all kind of plastic tools, because normally you don't want to use any metal. If you need to bend some plastic, you will just break things. So let's hope this will work. Okay, I think I'm getting there. You can see. Okay, that wasn't too nice sound, but let's hope nothing broke. I think there's a Wi-Fi antenna here. I think there were just plastic clips here. I don't think anything even broke the sides. It's quite nice actually that they haven't used like glues. Even the rubber things here covering the screws were just plugged in, no glue. It kind of looks like two PCBs sandwiched. I need to get this first one anyway first. Open any screws, it's good to check, are they the same size? So far these ones are. I really don't have proper tools for this, just a crappy screwdriver. I'm kind of trying to figure out what is attached to what. Do I still need to... got it off there. I don't think it was anything holding, it was just, they were just behind some plastic bits there. So you see there's a ground wire here going to the aluminium case. Then I should remove the flat cable. Cable going to the front. Okay, there's still something holding boards together. Oh shit, dropped something there. So you see, I'm not a professional doing this. Light is not very good showing what I'm doing here. Okay, so it was these two cables were holding the main PCB to the connector PCB. So just kind of need to carefully wiggle this off. And now I think the main PCB should get off. Yes. So we still have the connector PCB here, and this is just for the display, and this is for the knob. The same screws as the rest. Where it is a bit awkward to open something, especially I don't have a lot of experience in this, and when things are held together by something and you don't know what it is and you don't want to pull too much, and I still would want to use this, not to destroy it. And by the way, I did have 6-year Peter Tyson warranty, but I don't think I have any more. Okay, so this is the main block. It's aluminium. I don't know where I think these are just weights here inside to make it feel more premium. I don't know. But yeah, I don't see an easy way to get the top lid off. there's this plastic frame here. Anyway, I'm gonna leave this piece as is. I'm not so interested in this one. Okay, I will see if I can get the antenna cables off here. Yeah, there's UFL connectors. Okay, this is the main PCB. Let's start with the small board. So this is the board on top of the chassis. So here is the line in and here's the phono in. I can see from the PCB traces that the line input, it goes all the way here directly to this connector, so it goes directly to the main board. All this circuit here seems to be part of the phono input, so it's likely the RIAA circuit. And here we have EP950E, which seems to be HDMI audio transmitter, so that belongs to the HDMI connector. The USB here, it's routed directly to this connector, so the USB circuit is on the main board. Here's the SPDIF input. I suspect that that's also at least almost directly routed away from here because there are no other audio chips here. If you look at the phono input circuit, the opamps here are SA5532A. Here's the datasheet of the SA5532 opamp. As we can see, it's a version of the famous NE5532. Originally, this datasheet was released in '79. So yeah, it's an old opamp. I think it's almost the same. There is just one thing I quickly noticed, that the temperature range is different for the SA version, but it's basically the same, interchangeable. This is not a high-end opamp in today's standards, but it's been very widely used for decades. And for example, Douglas Self quite highly talks about it in his book Small Signal Audio Design. It's been very widely used, especially in pro audio, like mixing consoles and recording devices. There's some electrolytics here. Don't know if they're in the signal path, probably. Not that it matters too much here. And this is the phono ground banana jack here. So of these connectors going to the main board, looks like this is the digital high-speed signals and this is analog and proper power. These two are probably the phono input and the line input. And there's nothing on the bottom side of this board, just some traces. It seems to be that the ground plane is split here. I guess analog digital. Usually it's not something you should do, but it's probably fine here. Okay, and here we have the main board. I still haven't taken this one apart. It's in a slot here. So this one, it has at least the Wi-Fi and Bluetooth. The antennas were connected here. I don't know what's the big one here. Could it be memory chip? There are probably some local power here. At least I see some inductors. Okay, here we have the main board. I had a bit of a look at this, what's in it. Of course, everything I'm about to say is just educated guess. I don't have any inside information. I don't know what is here and how it's done. But here we obviously have power supply, a ready-made module. The main is the 12 volts. And then here you have other power circuitry around, and of course some local ones as well. So then you generate the rest of the supplies from the 12 volts. Here are two examples of the PMICs I found on board. So for example, this TI TPS7A 4701 is one of their top-end LDOs. It has a very low noise, very high PSRR even at the megahertz range, so it suits really well after switching converters. And the TPS65131 is a split rail converter, so it's a DC-DC converter with one boost and one inverter. And it's exactly the same chip I use on my 1-for-all power supply to generate plus minus 15 volts here. So this probably creates the negative rail for op-amps and such. I don't know if they use LDOs after this. I didn't spot at least any negative LDO I would recognize. This one is max 5.5 volts input, so they cannot connect this directly to the 12 volt output of the power module, so there must be something in between. Here we have the two connectors going to the top board. So this was the digital one, so that has a USB HDMI, and this one has the line input, phono input, and probably some power. This one here is a headphone amplifier, TPA 6120A2. I've also used it. Of course, the headphone jack is on the front panel, so it's not ideal. It's connected via this connector here, I think, to the front panel. So you have quite a lot of connectors and cables and thin wires in between, but there's a compromise you need to do. Here we have the line output, sub output, coaxial output, trigger, SPDIF output, and Ethernet. Okay, let's have a look at some of the main components here. Here we have the ES9038Q2M DAC, so that's the main DAC. And then here are the connectors, output connectors, so all this in between here, I presume, are the output circuit for the DAC. And the op-amps here are OPA 1612 and 1611. So that's quite impressive to have the top high-end op-amps in a device in this price range. So this ES9038Q2M is not one of their top range like the Pro models are, but it's very close to the top there with the -120 dB TSD plus N. If you look at the block diagram, we have PCM DSD interface. I suspect WiiM only uses the PCM because you cannot provide all the DSP functions with DSD. Then we have a set of oversampling filters. We have the filter selection in the WiiM app. The ESS DACs also support custom filters. I don't know if they use any of them, probably not. Then we have stereo DAC, and the outputs are voltage or current outputs. The datasheet DAC doesn't actually tell how do you select between the two. I think it's automatic based on some discussion forums. Overall, the datasheet is not as great as some competitors. ESS used to work directly with the companies, and I think that's still main way they work. You can now buy some of them from Mouser, but a while ago it wasn't even possible. So for example, there is nothing about the application circuit like we usually have in datasheets. So if you use voltage or current mode, what kind of circuit they recommend. I suspect WiiM used this in current output mode. That's the better performance. That's actually the only performance I think they state on the datasheet. So the spec numbers are for differential current mode. And then the op-amps we have at the output are probably then IV converter with some low pass filtering and output buffers, possibly with more filtering. If you look at the DACs in Mouser, as you can see, this is the Q2M. And this is the Pro model, so there is like 5x price difference between the DACs. And this is the op-amp used at the DAC output. So the 1612 is the dual version, 1611 is a single unit. And this is one of the top range Texas Instruments op-amps. The noise is around 5 times smaller than the SA5532. Distortion, they don't even say it for this one. This one shows some impressive low numbers. Of course, it always depends on the circuit you use and the implementation. And if we look at the price of these op-amps, so the 1612 is around £3 something, 100 quantities. Obviously, these are not the prices the companies pay, but they're still comparable. And the SA5532A is like 15 times cheaper, so there is a big difference. And here's the 1611. They probably could have used 1612 at the end of the output as well, but probably wanted to separate the left and right channels and use these single op-amps. The components in the audio circuits here look basic, as you can expect. Just normal SMD resistors, ceramic capacitors, some ferrites. There is one IC here close to the output, the closest to the output, what they also used here at the input. And I don't know what it is. It would be nice to know. I don't know if it could be some kind of protection. I don't know what's the big electrolytic here, but I don't think it's anything to do with the audio output because it's only one of them. So it kind of looks like they don't have, most probably they don't have any electrolytics on the signal path, which is nice. Here we have two more audio chips. PCM5121, and that's a DAC. That must be the DAC they use for the sub output because the main DAC is 2-channel. This is the PCM5121 DAC they use for the subwoofer output. It's quite a bit lower performance than the main DAC, but you don't need that performance in the sub output. It has charge pump integrated, so you don't need DC blocking caps for the output. You also don't need any opamps or any external filter, just a simple passive filter, so it's quite easy to use. Also has quite a bit of like DSP functions, some filtering EQ inside this one. It also has a PLL, so you don't necessarily need master clock, but I would think that they're not using any of these features, so I'm not sure why exactly to choose this DAC, but probably it was available for a good price and just fit the system. And here we have PCM 9211. I've used it as well. It's a digital routing, like you have SPDIF input output, a lot of PCM ports. It also has an ADC. I first thought that they probably use this ADC for the line input, but there's actually another ADC on this board, and it looks like the ADC pins on this IC are not connected. PCM 9211 digital audio interface. I suspect this is mainly used as an SPDIF receiver and transmitter. This chip has multiple PCM ports and quite complex routing options, so it's also possible they use this to combine the signal from other converters and provide simpler connectivity to the main SoC or main DSP. As mentioned, there's an ADC here as well. And this is the bottom side. So here, this one, it's just kind of quite close to the connectors going to the other connector port, and that is PCM 1863, which is a 4-channel ADC. So that's what they must use for the line in and the phono in, presuming that they use all the 4 channels instead of using external switch to switch between the 2 inputs. PCM 1863 4-channel ADC, I believe they use for the line input and phono input. It has PGA in it, so they can provide some gain, analog gain, instead of just using digital gain for the inputs. Again, it's a device that doesn't require an awful lot of external components, so you don't need any buffer op-amps or bias circuits, just AC coupling caps. In terms of performance, you get typical 110 dB dynamic range, and the THD plus N is not on the front page probably because it's not amazing figure in today's standards, 87 dB. So there's quite a lot of audio chips on this device. This one here is a GL852G, which is a USB controller, so that's used for the USB, although the USB connector itself is on a different board. And this one here is a Realtek 8152, which is an Ethernet chip and close to Ethernet connector, so it makes sense. So one thing is kind of missing here still is any sort of a big SoC. So I wonder if that's under here as well. So this could be like SoC, memory, and radios. So they can also swap this unit in the future if they want to change some in that without changing the rest of the board. And regarding the SoC, WiiM says on their own web page that it is a quad-core ARM Cortex A53 with 512 megabytes of RAM and flash. One interesting thing, there's this small hole here in the rear panel. It's not a reset button like in some devices. On the main board here we have what looks like a digital microphone. I couldn't find this part number on Google what it is, but someone in one forum said that it would be a microphone they use to synchronize multiple WiiM devices. There's a feature in the app that you can synchronize multiple devices for multi-room use. All the RCA connectors are isolated from the aluminum chassis. They are attached in the plastic frame inside here. That's quite common in audio devices, mainly to avoid ground loops or so, but it can cause issues where all the interference the shield picks up, it's actually directed into your audio ground. Also, I think the only place where the ground of the main board is connected to the aluminum chassis is this wire here. And this is definitely not low impedance at high frequencies. Also, if you look at the other connectors like the high-speed HDMI, USB, they can technically touch the case here, but because these are just standard connectors, there are no clips around, So nothing guarantees the connection to the chassis, so it's kind of, it may touch or it may not touch. I'm not an expert in this topic, shielding, grounding. It would be nice to hear from someone who is. Of course, the whole device is not connected to mains earth, it's the 2-prong socket. Of course, the whole device is also not covered by metal, the bottom is plastic, and you have the antennas here, probably for that reason. Putting the WiiM back together now, so I can listen to music again. Now, someone could be asking, like, are there any modifications I would do on this one? And I would say no. I just don't think that aimlessly changing components like capacitors makes any difference. Of course, there are always people who claim that they can hear all the difference even if you change the screws. But I just don't think that's reality. It's not practical. Before changing anything, you need to understand what the circuit is actually doing and what are the impact of the changes you do. You can easily make things worse. One kind of easy change could be changing opamps. Again, you may do more harm than benefit, but even with the opamps, they use top-end opamps here already, so there's no point of changing anything. I was actually thinking that I would modify balanced outputs here to use, for example, this kind of 1/4-inch jack plugs. I could just make them pseudo-balanced, so I wouldn't need to make any electrical changes on the circuit. But then again, like with any kind of modifications, you come to the questions, what problem are you trying to solve? I'm now using RCA to XLR cables and I don't have any problems. There are no interference, no ground loop. So why would I do destructive changes on this device when it's working fine? So I'm just gonna put it back together, enjoy music again. I hope you enjoyed the video and please subscribe and comment, leave feedback. Thank you for watching. Bye.